Download this code from codegive.com, link in the description below. React unable to resolve dependency tree error, a deep dive and practical guide. The unable to resolve dependency tree error in React is one of the most frustrating and common issues developers face. It essentially means that npm or yarn, the package managers, are unable to figure out a consistent set of dependencies that satisfy all the requirements of your project and its various packages. This often happens due to conflicting version constraints between different dependencies. This tutorial will provide a comprehensive understanding of this error, its causes, and, most importantly, how to resolve it. We'll cover everything from the error message breakdown to practical debugging strategies with code examples. Understanding the error. The error message itself can vary slightly depending on your package manager and the specific dependencies involved. However, the core message usually includes these elements. Asterisk unable to resolve dependency tree, this is the main indicator. It signals a problem with your dependencies. Asterisk found, package name at version, this shows a package that the package manager has found installed in your project. Asterisk node underscore modules slash package name slash package.json, this points to the location of the offending package within your node underscore modules directory. Asterisk peer dependencies, this section is crucial because it highlights incompatible peer dependencies. We'll explore this concept extensively. Asterisk could not resolve dependency, indicates a specific dependency that the package manager can't reconcile with the rest of the tree. Asterisk npm error. Code else problems or yarn, detected an error in the dependency graph. These are general errors that confirm a problem in the dependency resolution. Asterisk list of conflicting dependencies, a detailed list of packages that are causing the conflict, along with the versions they require. Example error message, yarn. 2. Common causes of unable to resolve dependency tree. 1. Peer dependency conflicts. This is the most frequent offender. Packages often declare peer dependencies in their package.json. This means I need these packages, with these specific version ranges, to be installed alongside me, but I'm not going to install them myself. Scenario package A requires React at 17.0.0, and package B requires React at 18.0.0. Your project can only install one version of React. This creates a conflict. 2. Conflicting transitive dependencies. A transitive dependency is a dependency of a dependency. If your project has direct dependencies that, in turn, have conflicting dependencies, you can run into this error. Scenario your direct dependency component library A requires LDAsh at 4.0.0, and your direct dependency utility belt B requires LDAsh at 5.0.0. Again, only one version of LDAsh can be installed. 3. Incorrect or incompatible version ranges. Using overly restrictive or incompatible version ranges in your package.json can trigger this error. Scenario you've accidentally specified a fixed version like React 17.0.2 and another dependency requires React 17.0.0. While 17.0.2 technically satisfies 17.0.0, forcing a fixed version hinders the package manager's ability to resolve broader version constraints. 4. Multiple instances of the same package. Although less common these days with modern package managers, sometimes a bug or configuration can cause the same package to be installed in multiple places within node_modules, leading to conflicts. 5. Outdated package manager. Using a very old version of npm or yarn can sometimes lead to dependency resolution problems because of less efficient algorithms and lacking support for newer package features. 6. Cache issues * corrupted caches of npm or yarn can sometimes cause dependency resolution errors. 7. Incorrectly published packages * rare, but possible. A package author might have published a package with incorrect peer dependency declarations. 3. Debugging and resolving the error, a step-by-step guide with code examples. Let's walk through the process of debugging and resolving this error using a practical example. Scenario *. Imagine you're building a React application using Create React App and want to add a date picker component. You decide to use React Date Picker. However, after installing React Date Picker, you encounter the unable to resolve dependency tree error. 1. Analyze the error message ***. First, carefully read the error message. Pay attention to the packages involved in the conflict and the version ranges they require. The error message will give you clues about the root cause. Let's assume your error message looks something like this, using yarn. This error message clearly states that React Date Picker requires React at *16.8.0 17.0.0, but React Scripts requires React at *18.0.0. This is a peer dependency conflict. Create React App version 5 uses React 18, which is not compatible with all versions of React Date Picker. 2. Check package.json***. Examine your package.json file to see if you've inadvertently specified conflicting versions for any of your direct dependencies. In this case, the problem lies with React Scripts, which is indirectly dictating the React version. 3. Solutions to resolve the conflict ***. Here are the most effective strategies, in order of preference. *A. Upgrade the incompatible package *. Check if React Date Picker has a newer version that supports React 18. This is the best approach. 1. Check the React Date Picker documentation or repository *. Visit the npm page, example https://www.npmjs.com/package/React Date Picker, or the GitHub repository of React Date Picker. Look for information about React 18 support. 2. Try upgrading * if a newer version supporting React 18 exists, update it. 3. Rerun install *. Try running npm install or yarn install again to resolve the dependencies. If the updated React Date Picker supports React 18, the error should be gone. *B. Downgrade React Scripts. Less ideal. Downgrading React Scripts is not generally recommended, as it might introduce other compatibility issues with other packages you are using. It is only useful if upgrading is not an option. Scenario *. If the latest React Date Picker does not yet support React 18, you could try downgrading React Scripts to a version that uses React 17. This is not recommended if you've already built a significant part of your app around React 18 features. 1. Check React Scripts release notes *. See which versions of React Scripts used React 17. 2. Downgrade, use cautiously. Potential problems *. This can lead to incompatibilities if you rely on features introduced in React 18. C. Use npm install force or yarn install force, last resort. Avoid if possible. These commands force the installation even if there are dependency conflicts. This can lead to unpredictable behavior and should only be used as a temporary workaround when you are desperate and understand the risks. What it does it disregards the dependency constraints and forces the packages to be installed. This can lead to unexpected errors at runtime. Example Why it's bad Runtime errors You might encounter errors because packages are not compatible. Maintenance hell It masks the underlying problem, making it difficult to debug and maintain your application later. Security risks. It can potentially introduce security vulnerabilities if conflicting packages have security issues. D. Use npm install legacy peerdips or yarn install legacy peerdips. Use with caution. This tells npm/yarn to ignore peer dependencies. Similar to -force, this can lead to unexpected behavior. Use only when you understand the risks and have exhausted other options. This option forces the package manager to bypass peer dependency checks. *E. Pin-specific versions in package.json, generally avoid, unless necessary. This involves explicitly specifying a version for each package. This can solve immediate conflicts but makes it harder to update dependencies in the future. Only use this if you absolutely need a specific version of a package and cannot use a range. Then run npm install or yarn install. 4. After resolution ****. After applying one of the solutions above, remember to ***test your application thoroughly. Ensure that all features, especially those related to the affected dependencies, are working as expected. ***commit your changes. ***commit your updated package.json and packagelock.json or yarn.lock files to your version control system. This ensures that everyone working on the project uses the same dependency versions. 4. Advanced debugging techniques. 1. npm ls package name or yarn y package name ***. These commands can help you understand why a specific version of a package is installed and which dependencies are pulling it in. 2. npm dedupe or yarn dedupe ***. These commands try to flatten the dependency tree by removing redundant packages. Sometimes, this can help resolve conflicts. 3. npm audit or yarn audit. This checks your project for security vulnerabilities in your dependencies and suggests updates that might also resolve dependency conflicts. 4. Deleting node_modules and clearing cache ***. Sometimes, the issue is with a corrupted node_modules directory or a corrupted cache. Try the following. Important ***. Be cautious using -force with cache cleaning, as it can sometimes cause further problems. Try cleaning the cache without -force first. Best practices to avoid dependency tree issues. 1. Keep dependencies up to date. ***. Regularly update your dependencies to the latest stable versions. This often includes bug fixes and compatibility improvements. Use npm update or yarn upgrade. 2. Use semantic versioning. Semver understand and use semantic versioning, major.minor.patch, when specifying version ranges in your package.json. Use caret for minor version upgrades and tilde for patch version upgrades. Avoid using ***, which can lead to unpredictable dependency updates. 3. Use a lock file ***. Always commit your package lock.json for npm or yarn.lock for yarn file to version control. This ensures that everyone on the team uses the exact same versions of dependencies. 4. Regularly audit dependencies ***. Use npm audit or yarn audit to identify and fix security vulnerabilities in your dependencies. Updates to address these vulnerabilities can sometimes also resolve dependency conflicts. 5. Be mindful of peer dependencies ***. When adding new dependencies, carefully check their peer dependencies and ensure they are compatible with your project's existing dependencies. 6. Consider a monorepo ***. If you're working on multiple related packages, consider using a monorepo, example using tools like Lerna or NX. This can simplify dependency management and make it easier to avoid conflicts. 7. Test before upgrading ***. Before upgrading any major dependencies, run thorough tests to ensure that your application still functions correctly. 6. Conclusion. The unable to resolve dependency tree error can be a time-consuming problem, but by understanding its causes and following the debugging strategies outlined in this tutorial, you can effectively resolve it and prevent it from occurring in the future. Remember to analyze the error message carefully, check your package.json file, and choose the least disruptive solution to maintain the stability and maintainability of your React application. Always prefer upgrading packages to downgrading, and use -force or -legacy peertips only as a last resort when you fully understand the risks. Regularly review and update your dependencies to keep your project healthy and secure.